At the Mercedes-Benz plant in Bremen, a new era of stamping operations is underway. Here, a high-tech servo press line by Schuler Group is deployed to form large automotive body panels, combining speed, precision, and flexibility to meet evolving production demands. The servo press line uses servo direct technology with freely programmable slide movements, enabling each stroke to be optimized for the material, die, and part geometry. In this 6-station forming line, blanks are fed into each press gap by an automated crossbar feeder, then shaped through multiple stations of bending, trimming, and forming. The result? High output rates, up to 16 to 23 strokes per minute in some configurations, and significantly reduced energy consumption compared with traditional mechanical press lines. For Mercedes-Benz, integrating this servo press line at their Bremen facility enhances capacity while enabling mixed material processing, from high-strength steel to lightweight aluminum. It's a key enabler of modern automotive manufacturing, where quality, flexibility, and efficiency must all align. Today we take you inside the world-leading manufacturing initiative of SANY Group, their global Lighthouse factories. Selected by the World Economic Forum's Global Lighthouse Network, these factories represent the highest benchmarks in intelligent manufacturing, digital operations, and heavy industry transformation. A Lighthouse factory is more than just automation. It integrates AI, IoT, robotics, and big data across the entire production line. For example, SANY's Beijing drilling machinery plant became the first heavy equipment factory globally to be certified as a Lighthouse factory, thanks to AI-driven logistics, 5G-guided vehicles, and material flows that cut lead time by 77%. Recently, SANY's Changshan No. 18 factory added to the network with full automation of 9 major processes: 540-plus sensors, 200-plus robots, and dramatic productivity gains, 123% increase in capacity, 98% improvement in labor efficiency. Step into the shop floor where massive components, steel frames, excavator booms, pump trucks, move through an orchestrated flow of robotic welding, laser cutting, AGV transport, and end-to-end digital tracking. Every product is assigned an ID card at birth, tracked through processing, assembly, inspection, and shipping, ensuring full traceability and quality assurance. From plate warehouses to welding cells, the visual harmony of machines, humans, and data streams underscores the new era of Industry 4.0 in heavy equipment. In a world where heavy machinery demands are rising, SANY's Lighthouse factories show what's possible when scale meets smart. These facilities are not just building excavators and cranes. They are building the future of global manufacturing, resilient, efficient, and digitally native. Here, inside a fully automated automotive manufacturing line, 45 KUKA robots work together to weld heavy ladder frames with unmatched consistency. This is industrial automation at its highest level, fast, precise, and perfectly synchronized for large-scale vehicle production. At the press station, the workflow runs continuously. This uninterrupted motion allows the system to maintain maximum welding speed, ensuring that each frame component enters the line exactly when needed. Timing and rhythm are everything in high-performance automotive manufacturing. During the framing process, side members and cross members are positioned together and welded to create the complete front section of the ladder frame. Robots clamp, align, and weld every joint with perfect repeatability, eliminating the inconsistencies that typically come with manual processes. The same automated closure system is repeated for the rear end of the vehicle frame. This ensures that both front and rear sections are built with identical accuracy before the next stages of assembly take place. Precision is critical, Subassemblies are positioned and welded immediately after joining. This rapid fit and weld method guarantees exact geometry and keeps every frame within the strict tolerances required for automotive safety and performance. On this line, pairs of KUKA robots collaborate in synchronized motion. Working together, they rotate, position, and weld components at angles that would be impossible for a single robot arm. This cooperative welding ensures optimal access to complex joints and uniform penetration throughout the structure. Next comes the marriage stage, where the fully welded front and rear sections are joined to become a complete ladder frame. This is one of the most important structural steps, transforming individual assemblies into the backbone of the vehicle. By the time this sequence is complete, the ladder frame is fully welded and structurally ready. Every weld, every seam, and every dimension is controlled by software and verified through automated checkpoints. Once welding is complete, mounting holes are pierced into the frame. Because the structure is already fully stabilized, the punching process produces no deformation, ensuring perfect alignment for downstream assembly on the automotive production line. At the final station, an integrated measurement system checks overall geometry and dimensional accuracy. Only frames that meet strict quality standards proceed to vehicle assembly. In this high-precision welding cell, Yaskawa deploys 7 industrial robots coordinated across 45 drive axes, a true leap in automation complexity and performance. With one central controller orchestrating all motion, each robot and axis moves in perfect harmony to achieve ultra-fast, repeatable welding operations. The system integrates multiple external axes, positioners, turntables, and automatic tooling changers, enabling complex welding paths, multi-robot interactions, and minimal human intervention. Yaskawa's advanced controllers support full external axis coordination with seamless welding integration. The robots adjust torch angles, avoid collisions, and maintain optimal posture across all axes. This setup excels in heavy-duty fabrication, where large parts need multi-point welding, high throughput, and tight quality control. In today's industrial brush manufacturing, high-volume production with precise filament length and density is vital. This machine produces roller brushes using folded filaments up to 200 millimeters in length, delivering both scale and quality in one automated line. The process begins by loading the polymer or wire filaments, which are folded to the required 200 millimeters length. The machine then inserts these folded filament bundles into the roller core using automatic tufting or anchoring mechanisms. Drilling, tufting, and trimming functions are integrated to maintain high speed and accuracy, while servo-driven controls ensure each filament bundle sits tightly and consistently. With real-time monitoring, the system adjusts filament feed and tufting pressure to maintain uniform pile height and density across the roller brush. Built with a rigid frame and precision motion components, the machine supports long roller cores and ensures stable tufting even with high filament length. The customizable program allows operators to switch filament types, tufting patterns, and roller diameters quickly, making the line suitable for industrial, commercial, and cleaning brushes. Standards for brush machines specify maximum filament lengths and hole patterns. For example, machines with a max folded filament length of 260 millimeters for certain applications.